Hi everyone, this is just a quick video on the mean absolute deviation, or the MAD, which is the measure of spread of a data set. So here's a question. It's actually in some of my worked examples if you see those, but basically I give you a data set. So you've got 5 values in this data set: 10, 12, 20, 20, and 28. So these are the 5 values in the data set. Let me get my pen going here. All right. There you go. So these are the 5 values of the data set. You want to find the MAD, or the mean absolute deviation, for these 5 values, and then interpret the MAD. In other words, what is the meaning of that value that we calculate? To find the mean absolute deviation, the first thing you need to do is you need to find the mean of the data set, because the MAD, the mean absolute deviation, is a measure of the spread of the data set. And one way to interpret spread, because spread is sort of a subjective term, is the distance from the mean. So spread is often interpreted in statistics as distance from the mean. And the distance from the mean is called a deviation. So there are 5 data values: 10, 12, 12, 20, and 28. To find the mean of those, and I'm going to use the symbol X bar because this is a sample rather than a population. Add those 5 values up, divide by the number of values. The number of values is n equals 5 in this case. When you add those 5 values up, it equals 90. 90 divided by 5 is 18. So the mean of the data set is 18. Now visually, what this looks like is this, and this is a dot plot, and I'll show you really quick how I constructed this dot plot. So the dot plot, here is the data set right there, and all I did was I entered the data into StatCrunch. I go to Graph, and if I scroll down, one of the options is dot plot. And you need to select the variable. My data was in variable 1, so I just select that, it paste it over, and then I compute. And what that does is that builds a graph like this, which you can resize and copy into other documents. So let's return to, here's the dot plot that I constructed, and this is just sort of conceptual. What we're doing, we're saying our mean for these data values is right about there. Our mean is 18. And so what we're doing with the mean absolute deviation is we're basically saying how far is each data value from the mean. So for example, this is the first data value. They'll call this one x1. Okay, each data value is as x1. This would be x2, and so forth. There are 2 20s, so that is x3 and x4, and the largest one, which was 28, was x5. There's 5 data values. So what I'm doing with the mean absolute deviation is you're finding the distance of each of these data values from the mean, and that is the distance right there. It is the distance from the mean for each of these data values. In other words, if you're a little person, how far do you have to walk? If you are positioned at this data value, which I think was 12, how far do you have to walk? How many steps do you have to take in order to get to the mean? All right, so here's how you calculate that. The distance from the mean is actually calculated by something called the absolute value of the deviation. The deviation is the distance, but that distance could be positive or negative. A distance being the data value minus the mean. So let's go back to this. I can say this distance for this data value of 12 for x2, that distance is x2 minus the mean. But notice what happens there. x2 minus the mean is 12 minus 18. Because when you find the difference, that is the distance, the difference is the distance, well, that equals -6. Okay, well, that's a negative distance. Okay, you can say, well, it's negative, it's less than the mean, it's 6 units less than the mean. But when I'm finding distances, I want to make these positive. So one way to make these positive is to take the absolute value of that distance. The absolute value of -6 which equals 6, which says essentially that if you were positioned at x2, you've got to take 6 steps to get from 12 up to 18. So to do that for each data value, I've done this here below. I've taken each data value, the first one being 10. This is for x1. 10 minus the mean, that's negative 18. Take the absolute value, that's 8. 12 minus 18, this is for x2, x3, x4, and x5. And these values over here are the distances, the absolute value of the deviation, or the distance. Remember, distance is a positive number. It has to be a positive number. So these are the absolute value of the deviations, okay, or the distances from the mean for each data value. Now, for the MAD, what you want to do is you just want to find the average of these distances. So there are 5 distances, 1, 2, 3, 4, 5 for the 5 data values. Add up those distances, so 8 plus 6 plus 2 plus 2 plus 10. Okay, and then divide by 5. That gives me a MAD for this data set of 5.6. So take the absolute value of the deviation, and then add up those distances, divide by the number of distances since there's 5 data values, and that gives us 5.6. Finally, what does this mean? Okay, a MAD of 5.6, and this is what the MAD is really good about telling. There are other measures of spread that are used, but the MAD is one that's most directly has a really clear meaning. A MAD means that on average, each data value in the data set is 5.6 units from the mean. So if I go back to my picture, which is right here, for example, x2 is 6 steps from the mean. x1, this one, is 10 minus 18. x1 is going to be 8 steps because it's 10 minus 18 absolute value. This is 8 steps from the mean. So what does the MAD mean? It means on average, when I look at the distances of these values from the mean, on average, they are 5.6 units from the mean.